Hello everybody, welcome back to my new series, and this series is going to be on cloud computing. So cloud computing is one of the hottest topic in today's IT industry. This is Balu here from Pradyumna Technologies, Bangalore. Now before we actually jump into cloud computing, first we shall try and understand what is this cloud computing and how do you actually define this word cloud computing. As you can see, this cloud computing is made up of two words. The first one is called the cloud and the second one is called as computing. Now what is a cloud? We all know what a cloud is. A cloud is a collection of water molecules. They basically consist of two atoms of hydrogen and one atom of oxygen makes one molecule of water. So like this, there are millions of water molecules, and all these water molecules put together becomes a cloud. Now what is computing? Now computing means using computer technology to perform a particular task. Now today we use computers for various tasks. Now it could be for reserving railway tickets, or it could be for internet browsing, or it could be for word processing, it could be for PowerPoint presentation or spreadsheet applications. Let us not think that we use computing capability only to make use of applications. We also use computing capability to develop applications. So development of a computer program or a development of a computer software would also need computational capability of a computer. Now, if a computer has to do this, what is required? We all know a computer must have a processing unit. The computer must have the required accessories in terms of hardware, like it should have a hard disk for storing data, it should have a random access memory, and it should have an operating system, a system software, and it should have a variety of softwares. Now all these things put together is called as computational resources of a computer. Now what is cloud computing? Now when you just take a simple computer, the hardware and software resources are limited. That means you have a computer with a particular configuration. So whatever resources you have, whether hardware or software, is limited. Of course, you can scale up the hardware and software as and when required, but at any given point of time, the hardware and software resources are limited. Now, what is cloud computing? Now, just try and understand and bring in the relationship between cloud and computing here. Many computers connect together to form one giant computing resource. So what I do is I put a lot of computers together and I bundle them up through some networking protocols and give the computational capability of all the computers to the end user. Then it becomes cloud computing. Now here the word cloud is being used because the cloud here refers to an internet. So I'll understand more about cloud computing when we see the other slides. So at this point of time, understand that many computers are interconnected together, and all these computers are connected together for what? They are all connected together to give their computational capability, added on computational capability to the end user. Now when you mean cloud, now that doesn't mean that clouds are the computers are actually connected in space. The computers are actually connected in earth, but you access these computers through internet. So this is what is a meaning of cloud computing. Now why do we use this? Why should we connect computers together, and what is the necessity of combining all the resources and accessing the maximum benefit of computational capability? I have taken a small analogy here. Let's say that you are a gaming maniac and you love games, so you basically wants to buy a gaming PC. Now in today's market, gaming PC is very expensive because the kind of hardware it has and the kind of software it has, it is very expensive. Similarly, for example, or if you are also going into video editing, even in video editing, what happens? The video editing PC is also very expensive. So what are the basic problems you have in both the kind of scenarios? In a gaming PC, first of all, it is expensive. So you have a lot of hassles of software drivers, upgrades, etc. For example, you install a driver, what happens? The driver may not basically talk to your operating system, there could be a conflict. Or you try and install a software, that software doesn't work on a driver. Sometimes you may have to go and replace the driver. So there is a lot of ifs and buts, and you have a lot of configuration conflicts happening in your gaming PC. And same would be in the case of your video editing PC as well. So now how do you avoid this? So what exactly you do? Suppose if I have a solution where somebody has already set up this PC for you somewhere in the internet, where you can access that particular PC from your browser. Won't that be very easy? For example, now there is a company called Adobe. Now Adobe has come out with a product called Creative Cloud. Now what is this Adobe Creative Cloud? It is basically a cloud computing technology where all the DTP softwares are actually put and you can use it from your own internet browser. So all you have to do is just sign up for Adobe Creative Cloud. So you have your Flash player, you have your Bridge, you have your character animator, you have your Photoshop. Now all these things can be accessed from your local system, and you can just access it after signing up into Adobe Creative Cloud, and you feel as though that you are working on your own system, but actually the scenario is you are actually working on a different system placed in one part of the world. So this is what exactly you mean by cloud computing. In this case, you don't have any hardware worries. Suppose if any hardware goes down, the people who maintain the cloud infrastructure will take care of the hardware. If you have any problems with the software upgrades, they will take care of it. So your job is very, very simple now. You can just concentrate on your work and you need not worry about the implementation part of it, because the implementation is totally separated from your job. Similarly, there's another cloud computing service called Shadow. It's called the Shadow Cloud Gaming Service, to be very precise. Now this service, which will make your gaming PC obsolete. Now once you sign into the Shadow Cloud Gaming Service, it is so good that you don't even have to have a gaming PC. You don't have to spend money on your gaming PC. You just have to connect to this Shadow Cloud Gaming Service and you can start playing games, and the kind of experience you get is very similar to as you feel when you're actually working on your local PC. And that is one of the main important advantages of cloud computing. Okay, now what are the other examples of cloud computing? See, we all use Gmail. Now Gmail is a solid example of cloud computing. Not only Gmail, we use Outlook Mail, we use Yahoo Mail. There are different kinds of mail services which are available today. So earlier, if I had to use an email system, then I have to install an Exchange server on a Microsoft NT machine. I have to configure it. Today it is so simple. You just have to create an account and start using it. Are you worried about who is actually maintaining the backup of your mail data? Or are you worried about who exactly is maintaining my email servers? Absolutely not. I'm only worried about signing into my Gmail account and I'm going to send and receive emails. So this is a solid example of cloud computing. Similarly, you have Dropbox. Now, Dropbox is a feature where you can store all your files. You don't have to have an external hard drive on your system today. You can store file in the cloud. Or Office 365. Now, for example, you may have MS Office installed on a system and you're working on some important project and suddenly your Microsoft Word crashes. So what would you do? You would land up into a soup. Suppose in the other case, if you are actually working on a cloud, you have to access your Office 365 in the cloud anytime from anywhere, and you don't have to worry about software crashes, and your data is also secure. So Office 365, LinkedIn is also an example of a cloud computing concept. You don't have to install LinkedIn on your system for social media networking, and Facebook as well. You don't have to install Facebook. All you have to do is sign it up, and you feel as though that you're working on the local system itself, but actually your Facebook servers would be kept anywhere across the globe. So these are some of the good examples of cloud computing. Now, what are the characteristics of cloud computing? Number one, you have an on-demand service on need basis. You use it when you need it. For example, Gmail. So what are you going to do with Gmail? Whenever you want to send an email, you log in. When you don't, after sending the email, you log out. On need basis. Use it when you need it. For example, your Adobe Creative Cloud. You want to use Photoshop? Log into Adobe Creative Cloud. Once your job is done, come back. So it is called as on-demand service. And how do you access that cloud? That is called as a network access. Internet is a medium of access. So if you want to access your cloud computing application, so the basic necessity is internet, and you need to have a computer with a web browser. So no internet, no cloud. So we have to be very clear about that, and the internet bandwidth should be pretty good for you to have a good fruitful experience. Then shared resources, resources are used by multiple clients. See, you are not only the person who is using Gmail. There are millions of people who are using Gmail, and there are millions of people who are accessing Facebook. There are millions of people who are accessing LinkedIn. So the same resources are being used by multiple people, and that is one of the good characteristics of a cloud computing. And next is scalability, allows elasticity of resources, very, very important. So let's say that you have a gaming PC today, and you have say one configuration of RAM. Maybe you have around 8 GB of RAM. Tomorrow you want to scale it to 16 GB. So if you want to scale it to 16 GB, what should you do? You should basically go to a hardware vendor, get a 16 GB RAM, and you'll have to install it on your motherboard, and you'll have to again unscrew the CPU, screw the CPU, or to do so many things. But in case of cloud, if you want to upscale and downscale your requirements, it is very easy. We'll see how to do that in the coming chapters. So scalability and elasticity of resources is an important characteristics of cloud computing. Scalability does not mean that you only upgrade your hardware. You can also downgrade your hardware as well. So you can either upgrade your hardware, downgrade your hardware. You can install and uninstall a software, and you can install and uninstall an application very easily in case of a cloud computing. Now, what is the main advantage of having cloud computing? You already seen that. So in make you to understand, I have taken a small case study. Let's say that you are an entrepreneur and you want to start a business. Okay, you want to basically start a startup company, and what is the kind of business you would want to do? You would basically want to set up an e-commerce portal. So you know what an e-commerce portal is. An e-commerce portal is a platform where you sell some items online. So when you want to do that, you need to have some expenses incurred. So to start any business, you need to have expenses. Okay. So what are the expenses? We categorize the expenses into two parts. One is called as a capex, and the second one is called as an opex. So capex basically stands for capital expenditure, and opex basically stands for operational expenditure. Now we'll try and understand what is the basic difference between a capital expenditure and an operational expenditure. Now let's say that you want to build an e-commerce portal, so you have to basically spend some money as a capital investment. That is your capital expenditure, your one-time money. So what that could be? So to set an e-commerce server, what would you need? You need a high configuration web server, right? You need a high configuration router. You need 24/7 power supply, very important. That means you need to have a backup. That means when you are actually hosting your e-commerce portal and people are accessing your e-commerce portal, it should not happen that somebody is buying some item and your server shut down because of the power cut. If that happens, the customer will have a very bad experience. So you need to have 24/7 server. You need to have some high configuration load balancers to balance the load. Then you should have air condition, that is to keep your server at an optimal temperature. You should have a clean room, and you should have cables and racks. Then in the software side, probably you may to have a Microsoft .NET framework. You need to have licenses to develop that e-commerce application unless and until you are using an open source. You need to have an SQL server, and you also need to have operating systems like Linux or Windows or whatever it is. So all these basically take some amount of money. So these are called as capital expenditures. Now can your e-commerce portal run only with capital expenditure? Absolutely not. It also needs to have operational expenditure. Now what is operational expenditure? The maintenance. You have to keep on maintaining your system. So you have to do house cleaning. So I have given you some examples of operational expenditure here. So you need to have maintenance staff, the people who maintain your server. You need to have a battery maintenance team. You need to have a team who basically cleans your clean room. So all these are the people who basically do the task on a day-to-day basis, who maintain your setup. So that also needs some expenses. So you need to have a professional IT team who manages your ticketing process and things like that. So all these comes under your operational expenditure. So starting up an startup business for launching an e-commerce portal would actually incur both operational expenditure and your capital expenditure. Now let's take a scenario where your company is going in profit. So what do you mean by your e-commerce portal going in profit? It is doing very well. Means that let's say that you basically hinted that the 100 people would use to you basically anticipated, say 100 people would actually log on to my e-commerce portal every day and do some shopping. But to your surprise, 1,000 people started logging in. You had not anticipated that. Now, when 1,000 people started logging in and they started doing transactions on your e-commerce portal, what happens? Your computer or your web server may not be sufficient to cater to 1,000 transactions. So what happens? The entire portal goes slow and the customer would become angry or he would give a wrong feedback. Now, what is an alternative? You need to scale up the server. To scale up the server, can you do it when the server is on? No, you have to shut down the server for a few days, talk to a system administrator, get the hardware and scale it up. If you shut down the server, you cannot shut it down because your company has just picked up and customers are actually seeing your website. Suddenly the website shutdowns or the portal shutdowns. It's going to be a bad experience for your customer. So that's the problem. You need to understand. We need to see how to tackle this problem. That is on the one side where your company is showing profits. So scale hardware, software by upgrading servers. Time consuming does not happen overnight. Suppose if you want to scale the hardware or software, it does not happen overnight. You just cannot scale it overnight. You have to shut down your system for 2-3 days, scale it up, do some performance tuning, and again come back to normalcy. At the same time, let's say that your e-commerce portal is not doing well. You anticipated 100 transactions a month and you're not even getting 2 or 3 transactions, and you waited for 2-3 months and nothing is happening. Your operational expenses are incurring much higher scale and you're losing money. So what do? Finally, you decide that you want to shut down the business. So when you want to shut down the business, what is that you do? You want to sell off your hardware. So probably you can sell off your hardware at an lower cost. But what happens to the software licenses you have purchased? So whether your startup as company is either doing profit or it is either doing loss, it is very difficult for you to manage them. So how do you overcome this? What is the best idea to overcome this, or what is that which can help you to come out with a headache-free solution? So that is cloud computing. So now what exactly is cloud computing and why do you need cloud computing is, now you have to ensure that somebody gives you the resources in the cloud and you access those resources as and when you need it, and scalability has to be done very easily and implemented very easily. Now how do we do that? The solution is nothing but resources in the cloud or cloud computing. Now have a look at this particular picture. Now you already have companies like you have companies like Amazon Web Services and Microsoft Azure. Now all these people basically gives you cloud computing services. Now what they basically do is they have servers, they have backup storage, they have bandwidth managers, everything put in the cloud. You use it when you want it, and after you have finished your job, just sign out and say goodbye to the cloud. That's it. So this is the solution, and you can use the services of the cloud from any device. It's not that you have to use the services of the cloud only on your mobile phone or on your laptop. You can use a tab or you can use any gadget to basically access that particular cloud through internet services. Probably only constraint is you need to have an internet to basically connect to that particular cloud. So that's the solution. Or the company comes and says, hey, I'm giving you the infrastructure, and you use that infrastructure, and after using the infrastructure you relinquish the infrastructure. That's it. That means your job is done. So this is one of the good solutions of how to overcome the problem which I told you in the case study. Now what are the main advantages of using this solution? One is service on demand, engage when you need, and no time limit. So now you want a service. For example, now you want to work on say Photoshop. What is the thing you need to do? Just sign up, log in, and all you have to do is use the cloud Photoshop and start working on it, and no time limit. You can work on for Photoshop for 24 hours, 36 hours, 48 hours. There's no time limit, and self-service allotted immediately. That means when you want something, that particular service will be allotted to you immediately. Not like you want a particular application to be installed in your local system. For example, you are a software programmer, you are working on .NET, let's say, and suddenly a project on Java comes. Now you want to install Java. You don't have Java on your system. So what do? You have to basically send an email to a system administrator. The system administrator has to take an approval from the project manager. The project manager has to approve it. Then the administrator will install Java on your system. So it takes a lot of time. But in case of cloud, it's not like that. Everything is available on the cloud. All you have to do is just change from .NET to Java. That's it. That means it is allotted immediately. So you save a lot of time and pay as you go. Very important. If you use server only for 10 hours, pay only for 10 hours. And if you are using only 100 GB of hard disk space, pay only for 100 GB. It is like, your local electricity board. The electricity is available to your house 24/7. But do you pay the electricity for the entire 24/7 availability? No, you only pay for the units consumed. If you consume 150 units per month, you only pay for 150 units what you have used. The same analogy holds good even for cloud computing. So you have to pay for the resources what you are going to access. You are using server access for say 2 hours a day, you only have to pay 2 hours per day charges. So this is what you call as pay as you go. And if you think that you first you have chosen 100 GB of hard disk space in the cloud, you feel that 100 GB is too less. You want 1 TB, so you can scale it to 1 TB easily. Or tomorrow you feel that 1 TB is not sufficient. I want 5 TB, so you can scale it to 5 TB easily. Or after a few days you feel that 5 TB is too much. I want to downscale it to say 1 TB. You can downscale it. So you can upscale it or you can downscale it, and it is very easy to do so, unlike your scaling or upscaling or downscaling in your local machine. So this is called as rapid elasticity. So rapid elasticity means you can upscale or downscale the configuration. Now, given you the architecture of cloud computing. So there are 3 layers of cloud computing, what we call it as service layers. So you have software as a service layer, which is called as SaaS. You have platform as a service layer, which is called as PaaS, and you have infrastructure as a service layer, which is called as IaaS. So you have software as a service, and you have platform as a service, and you have infrastructure as a service. Now these are the 3 layers of cloud computing, and different types of end users use all these 3 layers. For example, you have an end user who use software as a service. They consume the application. So what do you mean by consuming the application? They make use of that particular application to do their day-to-day tasks. For example, your Office 365, your Gmail, your Google Apps, they're all actually placed on software as a service. Now, if I want to use any one of these applications, I just have to log on to that particular site and sign up and start using it. But if you are a developer and you want to develop your own application, then you use platform as a service. For example, you want to develop an application on ASP.NET. So what do you do now? You need to have an ASP.NET framework. So how do you get the ASP.NET framework? Now I have to access the platform as a service layer, and I have to build my application on that ASP.NET framework. Now apart from that, I also have frameworks on open source, like I have PHP framework, I have content management system framework. For example, I want to develop a learning management system, so I have a Moodle framework, I have a Drupal framework. So there are different types of frameworks which are available, and for those frameworks you can basically create applications and build on it. Then similarly, you have infrastructure as a service. Now this is the actual metal layer of your cloud computing system. That is, all your servers, your cables, your racks, and everything is placed in this particular layer, and the system administrators are the end users of this infrastructure as a service. So you have a legacy system. I can migrate the legacy system to the infrastructure as a service layer of your cloud computing. So now the end users of an infrastructure as a service would be your system administrators. Now the developers would be the end users for your platform as a service, and examples of that would be Microsoft, Azure, Rackspace, etc. And the end users would be the general system end users who basically use software as a service in terms of Office 365, Gmail, Google apps, etc. So this is the basic the concept of cloud computing, which I try to explain it to you in a nutshell. Similarly, you have other concepts coming up in my next video series. I'll talk in more depth about what are the various models of cloud computing, and we should also take one cloud computing example and deal it in detail. Okay. If you like my video, give me a big thank you, and don't forget to subscribe on my channel and also follow on my Facebook page. I'll see you soon in my next video session. Till then, take care. Bye-bye.